Thank you, Olivia, for this very warm introduction. Hello, everyone. It's my pleasure to be here to talk about the LoRaWAN technology evolution. I'm sure many of you are already enjoying this technology. And I'd like to briefly talk about how we have evolved it since 2015 and what is ahead of us, touching upon the ongoing work items. So this is our current end-to-end architecture, and you might think that we have all started with this full architecture. But if you go back to year 2015, what we had was a single protocol, over-the-air protocol, that ran between the end device and the so-called network. And starting from this single line between the end device and the network, we have grown it to a full end-to-end architecture that involves multiple network elements and involves radio extensions through relay and all sorts of applications riding above that. And this evolution has been recently captured in this diagram, as you might have caught it on the social media. And what I'd like to do is to dive into the technical details to show what is under the hood. And for that, we have this diagram that shows the technical specifications and how they have evolved starting from year 2015. So, like I said, at the very beginning, we had a single protocol, which was called LoRaWAN, which later we would start calling it LoRaWAN link layer. And in that era, we have only focused building basic networks. And what started as a single specification, when the year 2016 came in, we have split into two, the link layer spec and the regional parameter specification. The reason being, we did not want to pace the regional parameters development to the link layer spec, because every year we were adding new countries and refining the channel parameters for various countries, and we knew we were going to have a more iteration on the regional parameters. So that's when we had two documents. And when we entered the year 2017, we started decomposing the so-called core network. What appeared as a single element, now we have broken it into network server, joint server, and application server in order to enable functions like roaming and activation. Roaming is a very essential functionality of LoRaWAN, which allows networks to get stitched together to provide coverage extension to each other. And today, we are able to do roaming among public, private, and community networks, both terrestrially and also in space. We have several examples of that you can learn from the members outside. And this is the era where we entered the interconnecting networks era. And you see there are different color coding here. The blue in the middle is the link layer evolution. And below that is the regional parameters, lighter blue. And the yellow work stream is the backend. And moving forward, what came after that era is the scaling device management. So as you see, over time, we keep adding new work streams in order to address the needs of the market. So this is a very much an alive architecture that keeps evolving based on the needs of the market, especially in response to the members coming in here and representing the market needs and their customer needs. The third era is the scaling device management, and it started by the definition of the multicast management and also the fragmentation, which constituted the foundation of what we called firmware update over the air, which basically involves having large files that gets chopped into pieces through fragmentation and then spread to hundreds and thousands of devices all at once using physical multicast, the most efficient way of pushing large files to end devices. Those files might be the firmware or they may be large configuration files, it doesn't matter. But what really the market needed was the firmware update over the air, the FUOTA feature. So that's what we have the device management workstream started with. In the following years, now entering the 2020 or 21, we started paying attention to the application domain. Until then, we said, okay, application domain is totally outside our control. We provide them a transport. But the nature of unlicensed band use is so special, we realized we had to do some special adaptation in order to facilitate onboarding existing application domains. And we have started with DLMS, the metering standard, and in conjunction with the DLMS UA, we started providing adaptation of LoRaWAN to support DLMS. And we have realized the way to integrate the two domains was to start supporting IPv6. But given that IPv6 brings a large overhead, also followed by UDP or TCP header, which cannot natively fit into the LoRaWAN payload, we started collaborating with the IETF, Internet Engineering Task Force. And in the LPWAN working group, we have contributed to the development of IETF SHIC protocol, which is an adaptation layer that can profile IP and higher layer headers, and also compress them so they can fit into LoRaWAN frames. Also, we've been taking advantage of the SHIC's fragmentation as well. And that's how we introduced IPv6 over LoRaWAN, which started opening up practically many IP-based applications to ride over LoRaWAN. And again, around year 2022, we have published a technical recommendation that describes how roaming hubs work, which is practically a direct application of the backend roaming API. But in order to facilitate the market's adoption, we have this recommendation that describes this new entity, which in fact uses the existing interfaces we have developed. And ever since then, we've been enjoying the accelerated adoption of roaming as the roaming hubs become more utilized. And again, the same year, 2022, we have introduced the relay. Obviously, we do have a pretty long range with LoRaWAN over LoRa using unlicensed band. Nevertheless, physics has its limits. There will always be cases where a device being at the bottom of a well or behind super thick walls won't be getting the signals from a microcell gateway. And that's where a LoRaWAN relay, a better operated LoRaWAN backhaul entity, node, and element, would come into rescue. And we have introduced that into our architecture as well. And now, fast forward to 2024, we have a number of work items we're working on along these different work streams. Starting from the top, the GS1. So again, this is another organization, GS1 Alliance, we have a liaison with, and what GS1 does is, it's all about standardizing the NFCs and RFIDs. And now we see in the market there's interest for building LoRaWAN backhaul readers of NFC and RFID. Then the question came, how do we transport GS1 identifiers over LoRaWAN in the most efficient and reliable way? So we formed a joint task force with the GS1 Alliance to produce a new document, which we are pretty close to publication. I would say towards the end of the summer, you can see this publication. And that is one way for us to tap into an existing application ecosystem. And we are also eyeing several other such application domains. And I would highly encourage you, whether you're a member or not, to let us know if you see an opportunity where LoRaWAN could come in. And if it cannot be used as is, and if there's any guidance needed or any kind of adaptation, we'll be more than happy to hear about that use case and work towards that. Then on the device management, we're working on device migration as networks sometimes are merging or fleet of devices migrating from one network to the other. We are adding new tools to our device lifecycle management. And device profile management is another such tool we are working on. It's a work in progress as well. It's about when you have to activate a device on your network server, you need to provision the so-called device profile. which is a number of booting parameters and the capability of the end device, which needs to be known to the network server. Today, this is done manually by various proprietary means. Now we are building an interface such that the network servers can download device profiles from centralized servers. So there would be a new type of servers coming up that will host device profiles from many, if not from all devices in the market. And your network server can automatically download these device profiles without you having to download manually or receive them in an email attachment and then plug them into your network server. Then on the backend side, after we have decomposed the network into network server, join server, application server, and also the gateway, we've been working on filling in the gaps, the missing links, one of which is the network server to gateway interface. Today, there are multiple proprietary interfaces, APIs, used for that. Now we are working on a standard one, which will not only be interoperable, but also it'll be superior to many of these available in the market. And similarly, the network server to application server interface, which hasn't been defined up until now, because in many cases, the network server and application server are co-located. But obviously, the architecture allows them to be split into two. And when that happens, we need an API. And this is what we are defining. There are various relay enhancements after the first release. And the mobile gateways. This is another coverage extender. What is behind that is the walk-by, drive-by reading, which people may be familiar with other technologies having that, like wireless M-Bus. So today, one can already build walk-by, drive-by reading capability or a mobile gateway to collect data where there is no permanent base station. Now, even though this is already doable, what we're working on is optimizations such that this can be achieved with minimum power consumption and also minimum consumption of the bandwidth. And the satellite connectivity, again, it's already commercially available from multiple providers. We're working on further optimizations to work towards supporting commercially off-the-shelf devices. And crypto agility. This feature is about supporting ever-growing list of crypto suites. Today, we have the state-of-art crypto algorithms we're using based on AES-128. But as we all know, as time passes, there will be new crypto suites, and the networks would like to adopt them without having to overhaul their full stacks. And we are building the dynamic negotiation between the end device and the network server, and the joint server as well, to agree on what crypto suite to use. So coming up with the new release of the link layer spec, we will have this feature built in, which will provide us future-proofness. And yes, this lists all the ongoing activities. And as you see, our architecture is growing in multiple dimensions, and we're adding new work streams. Like I said before, they're all driven by the market. Hopefully, you are already a consumer of this technology, but if you'd like to be on the producer side, on the contributor side, I would like to encourage you to join the LoRa Alliance, join the technical committee, join various task forces under the technical committee. The task force participation, adapter level members and any level of members can be participating in the task forces, so it's open. Please do join. And majority of the work does take place in the task forces, and then they go to the committee level for approval. That's where we need contributor level membership or above, and then they go to the board, which requires sponsor level membership. But as you see, we do have opportunities for engagement for any level of membership. So I hope to see you at the TC meetings or at the various task force and working group meetings in our committee. Thank you for listening.